First of all, thank you. Thank you for the invitation to talk here. My name is Alejandro Hevia. I'm a professor at University of Chile. I'm the head of the Randomness Chile project, which is a randomness beacon that we have here in Chile. There are a lot of people behind this project, so I would like just to thank Camilo Gomez, who is the lead developer, but there's many people doing the fantastic job here, so it's just not me. So I was asked to talk about some applications. I would like to talk some applications of public randomness that we have developed in Chile. So even though they use our beacon, the idea is that they could use something like the League of Entropy, actually randomness generated by DRAN or something like that. So just a quick head up here about what we are. We are essentially, we started working in 2017 to try to create somehow an extension of try to replicate and extend the randomness beacon by NIST, but with a particular goal was to provide transparency and trust to digital services that rely on randomness, okay? Our idea was to use this in a way to provide transparency to some processes. And this is something I would like to talk here. I think Luke mentioned it before, but just a point is that our beacon, although it uses a similar approach as the one by NIST, we have a different way to generate randomness in the sense that we sample different sources. Particularly, one of them is the source from earthquakes. So that's why the seismic girl is standing on top of the earth moving. So we like that pretty much. And so let me just go into the point right away. Since the motivation was to provide transparency, we decided to look into places where transparency was an issue, in particular with randomness. And in Chile, we do have, as in most countries, we have an agency which is in charge of auditing the expenditures of taxes, you know, how government spend taxes, whether they actually do it following all the regulations and in proper ways. Here in Chile, it's called Contraloría General, which for people in the US, it would be something like the Comptroller General. This is the independent agency in charge of preventing essentially politicians to mismanaging the funds. And what they do is they actually do a random selections of people, of government officials for audits. And the main problem they had for a long time was that, of course, they don't have enough funding to do audits in every single government official. So they had to pick people at random. And because of the process was not really that transparent, they were frequently accused of political persecution. So for them, when we approached them to tell them, look, you can do this in a verifiable way, they were really excited because that would be a way to provide more transparency to the whole process. So you guys have an idea how this works. The main idea, this is one case, but the main idea in this particular case is that you have a process in which you have a universe, a list of all possible government officials who could actually be subject to audit. And the idea was to select some of them at random. Of course, in practice, it was a little more complicated, but the overall idea was that we managed to create a way in which we could take some of these inputs and make them public, make this input in public here. And somehow the whole selection process was being done outside of this agency using the output of a particular pulse from the beacon, or particularly it could actually be a particular day. For what exactly happened here is that the Contraloría actually commits to perform this selection, say on January 1st to noon, and on that day it just provides all the inputs in a website, and the selection is being done with the pulse, with the randomness from the pulse of that particular date and time. And the output actually is also public. And the whole process is designed in a way that you can recompute it, okay? Again, any external observer can recompute it. So that's quite an interesting aspect to do the verification. Of course, there are many details. The selection needs to be done in a way with is based on a particular number, which is called the risk factor. And the risk factor, there's several buckets of risk factor. So there is a little more complicated selection, but it can all be done and actually could be recomputed by any external observers, provided that they know exactly when this took place, so they are able to recover whatever randomness was generated in that moment and recompute. There are more details, and the more detail is that this is the most basic aspect of the selection. There's some other selection that requires to use data which might be sensitive. So you might have some private inputs. Let's say sometimes the risk factor associated to a particular government official is based on other data. Let's say how much money they make, whether they have properties or not. And that information might be sensitive to reveal. You cannot reveal it. So we have a second solution in which you use commitment and using some range proofs to prove that people belong to a particular bucket of risk. So you can actually select it with a certain distribution there. So we did that. Unfortunately, this is a project that's been on hold at this moment because, of course, like everyone in the world, we are going through this pandemic, and this is, we hope to resume this project soon. But actually, one of the key issues here is that the process to provide transparency is even though it might be simple initially, providing transparency when you have private input requires some testing, because you need to convince people what we are doing is correct. And we believe that according to our initial prototypes that we're actually doing it. And there is another so can you hear me?
Yep.
Yes.
Okay. Somehow of course, computer got frozen somehow. Hold on, just give me 1 second. Here we are. Right. Sorry. I apologize. Right, and there's a second application that we have is that to be able to, with the electoral service in Chile, you probably don't know, but in Chile, the poll workers are not government officials, so they have to be selected by, they are selected at random among all the citizens who are able to vote. And of course, that for a long time, there was a source of controversy because people were complaining that they were selecting again and again, and the process was not really fair. So we use the public randomness to actually provide a more transparent process there. And in a more interesting application is that in a project, in an initiative that is being done with the Chilean Congress, we created a particular scenario in which this is called deliberative convention. Is an idea from political science, actually from Professor James Fishkin from Stanford, to invite random citizens to get together and to talk about a policy, some policy options about, medical care, some policy related to the country. And the idea is to bring a subset of all citizens to discuss about this issue, and hopefully, since it's a random selection, the output of this discussion is more representative for the country. And we actually, this is something that has been done in other countries, in the US, in Europe. This is for the first time will be done here in Chile, and our participation is to provide the random selection of the citizens, which is actually a way to everyone to get convinced that this is a fair process, and every people in the country has the same chance to participate. There are some smaller projects that we are working on. Just mention a few. As mentioned before, to be able to audit elections, risk-limited audits. We have some interesting project with private randomness to try to provide verification of a certain process without really revealing the randomness being used in a way that's more specialized. And of course, some of the other projects you have discussed here before about using a consensus algorithm and so on. So I'm pretty happy to answer some questions later, but our goal here, just to mention, there's uses here of randomness, which are very, in my opinion, very important for the transparency of certain processes, especially those which involve decisions that affect a large collection of people. I will believe there is plenty to do there. So thank you.